We are live. Let me fix this. Welcome. Got some really cool stuff today to share. Starting with an article that I wrote on hyperparameter tuning that I'm about to post, and that I'm going to go over. It's going to be cool. So, where is this? Articles. This should be all ready to go. And then I'm going to go over it. Let me just make sure that my sleep-deprived brain did not do anything stupid in here. Benchmark, code, experiments, random. Looks good. All right. And my stream, I should be able to post the article link as well, right? Yeah. And then I'm going to go through this because it's pretty cool. Cool. So, we've got some fun stuff. If I go grab the article real quick. I did this over the weekend. Basically, what's going on here is I've been using Carbs for a while now. Carbs is this hyperparameter tuning algorithm from Imbue. And it seems like it's been working very well, but it's kind of hard to get like comprehensive comparisons to Bayesian sweeps and stuff. Especially when like a lot of the time we're just solving the environments with everything anyways. Yeah. So we needed more comprehensive comparisons to stuff. So I came up with a test for this that's very, very unfair to Carbs. I came up with like the worst possible benchmark for Carbs to see if it's still better. The idea being that if it works there, then it's probably safe to use wherever. And it just absolutely shreds. So let me go through this. So first of all, if you'd like to support all this stuff, Star Pufferlib, this article's on X. It helps me out a whole bunch. I'm going to put this in... Let me see. Can I put this in the chat? I'm going to put the article in the Restream chat. So, what is Carbs? Carbs is an algorithm that is based off of Bayesian hyperparameter tuning, which attempts to maintain probability estimates that tell you what hyperparameters you've explored are probably good. It augments that with the ability to maintain lots of different sets of hyperparameters that depend on how long the experiment took. So, like, you could have an experiment that gives you a decent set of hyperparameters, but it's very fast to run. That's just as promising as a candidate as something that gives you very good hyperparameters, but takes a really long time to run. And it explores in many different directions. And as it hones in on what is good, it will use more and more compute to try to get better results on all of the good different sets of hyperparameters. That is the main selling point of Carb. And that is, like, unquestionably good. But that's not what I'm testing today. Carbs also just has a bunch of extra tricks that have some heavy math in them that seems reasonable. It all seems reasonable, but, you know, who knows if it actually works more broadly. So what I did is I came up with a synthetic task that should be very hard and should give Carbs a really good opportunity to demonstrate whether it is good or not. So here's the benchmark. We do have results of real sweeps. We use it all over Pufferlib. This is not what that's about. Hi, Noah. What's up? We're going through this new article I wrote. So this is a controlled synthetic test. What I did is I wrote an environment that just gives you 10 variables from a uniform normal distribution. These are secret, and these are considered the optimal hyperparameters. Okay, so you have like 10 optimal hyperparameters that are sampled by this fake benchmark, this fake environment. And then the hyperparameter tuning algorithm, instead of training networks, it's just going to tell you the hyperparameters that it would use to train a network. And without having to train a network at all, I'm just going to compute a reward based on how good your hyperparameters were, how close they were to these optimal held out variables. I designed this function below to be smooth and also to be very hard to optimize because it goes to 0 if you have a single hyperparameter that's really, really wrong. You have code and math here. Take your pick, whatever is easier for you to read. The way that this works, though, is that you do a L2 distance, so squared distance between the hyperparameters. Well, not quite L2 because I don't do a square root, but you take squared distance from the parameters to the optimal hyperparameters, and then you take 2 to the power of negative distance here, which is this component right here. And then you add a little bit of noise. And what this gives you is it gives you something that decays as you go away from the optimal hyperparameters, but it never quite goes to 0. And then you multiply all the numbers together. So if you have a single number that's really close to 0, then your reward is going to be basically 0, though it's not exactly 0, which is important. So this is the benchmark. For the experiments, each algorithm gets 100 samples, so 100 like trials, in order to evaluate what it thinks the optimal hyperparameters are. I have the source code for this. I think I forgot to put it at the bottom of the post, but I'll edit that in. It's on the Puffer GitHub anyways. I tested out random search, very simple genetic algorithm, WandB's built-in Bayesian search, and carbs. And the graphs are all public on WandB as well. We have all these right here. So you can see that we have... Okay, apparently this needs to be... I need to free up some storage, but they are all public. First of all, random search from WandB doesn't do anything. Everything fails. If one hyperparameter is off by a lot, then you're not going to get anywhere. And since they're 10 hyperparameters, that's basically guaranteed. So random search fails utterly. Genetic algorithm, I wrote this just for fun as like a little test. It's actually surprisingly good. All this does is it just picks a set of random parameters, and then it will mutate them all by like a small noise amount every single trial. And if that does better than the previous one, it keeps the new ones. So this takes a lot of trials to get anywhere, but once it starts taking off, it actually starts going up quite nicely. And it produces these really cool graphs where like it's essentially all centered around an initial distribution, and you can actually kind of see the optimization process over time because it's like it's one candidate set that it's changed from, which is cool. Then we have WandB Bayes. It's inconsistent. It can perform better than this. But, you know, on the last set where I just ran everything from scratch, this is the number I got. I've seen it do like 0.5 before. But this kind of a trend is very common where, like, it just doesn't latch on to the good trial particularly well. And it's not particularly efficient. So it gets a couple things that have non-negligible performance. The maximum is 1.25. Here we get 0.25. But overall not great. And then we have carbs, which just solves the problem. Like, perfectly. It just gets better and better over time, and then there you go, this is like 0.9 something. And you can see over time all the different runs, right? You can see that it started out down here and stuff wasn't going very well, and then it kind of found this distribution over here. So, like, because it can maintain multiple different distributions. So carbs just shred stuff. And this has been pretty consistent with what I have found using this algorithm. The fact that the genetic thing kind of works a little bit, I actually would really like to have a WandB Sweeps API where it's super easy to just swap in your own sweep methods. I think that that would be so much better for everybody, because then we could just extensively validate all these things, right? Like I could make a bunch of benchmarks like this, and we could extensively validate hyperparam tuning. But in the meantime, carbs just shreds, and that's it. This is the worst possible case for carbs. This doesn't even allow it to make use of its dynamic compute. This is just the other tricks that it has, and it still wins in the worst possible case. I didn't game this. I didn't spend a month doing this to make carbs look good. I did this in like 5 hours on Saturday, and it just worked, and it's relatively consistent with everything I've observed previously. So there you go. Carbs wins. And the thing that I really, really like about this, there's this really nice side effect when you have good hyperparameter tuning algorithms. This basically means that when I have an experiment and I run a full sweep, like let's say I have an environment and I run a full hyperparameter sweep on it and it still doesn't work, will this be archived on YouTube? All of these streams are archived on YouTube. Everything that you're seeing here is immediately saved to YouTube as well. It's live on YouTube, Twitch, and X at the same time. How do you do parallel coordinates with carbs? I have an integration with WandB. This is currently Puffer exclusive until WandB integrates this natively. I'm hoping that they do, but you can get this in the Puffer dev branch. There's a little hack that you have to do, like to trick WandB into allowing you to update parameters at runtime. But there you go. This is so great for RL. Like, the thing that I like about this, not only does this let you get a good set of hyperparameters, right? That's obviously important, but think about it the other way around. Like, in reinforcement learning, if you have an environment that you're trying to get working, and you run this full sweep, and it still doesn't work, it means your problem is probably not the hyperparameters, right? Because if they're good hyperparameters, it will find them. That's the really exciting piece for me. Because, like, I think I have one of these where I gotta delete something so it lets me see my storage. Hold on. Shit. That's really obnoxious. Screw it, WandB. You're worth some money. Hold on, let me just put this in on the other screen. Hold on. Let me give thank you. Let me give WandB some money and then I'll have more stuff. They're worth some money anyways. Okay. So hey, thanks for dropping by. I'm trying to make RL less cursed overall. I just paid you. Come on. Let me see. Let me see my data. This looks so good. GG Bayesian. Twitter post should go. I hope so. I mean, I have kind of been doing like some engagement optimization lately, trying to get some bigger posts. But like, the thing is, it actually helps so much with my work. Because at the moment, this is all just open source stuff, right? And like, the more people that see this, the more I get people interested in contributing to the project, the more I have people testing this and using it, like, the more like companies maybe start using it, right? It's all just really, really helpful. And the more I have to like, I get to not think about this stuff and get to just do dev. So yeah, the promo helps a lot. And also, speaking of which, if you want to help me out a whole bunch, Puffer is almost at 700 stars. Almost at 700. So if you want to go start this repo, helps me out a ton. Let me show you some cool stuff, providing this will let me access my data. So I have a couple of sweeps from here that I've been working on. 3 days. Hold on. Where is this thing? This one any good? No, not this one. That's old. Oh, right. I have a carbs project that has all the carb sweeps in it. Perfect. So you can see the number of runs that we have here. This is a MOBA sweep. And I think this one doesn't work particularly well. Yeah, these rewards are very low. But basically what this means is the fact that these rewards are low means that I have a problem with the environment or the reward function. It's not in anywhere else. And you can tell that just because, like, look, it's tried all sorts of different things. Okay, we have validation that carbs is a good sweep algorithm. This is done, like, let me think how much this is done. This is way over 30 billion steps worth of data right here. Because each of these runs is at least 100 mil. I think actually they're like 200 mil, most of them. So yeah, this is probably like 50 billion steps worth of hyperparameter tuning data on the MOBA. So it looks like I broke something with the reward. But I can be very confident that I broke something with the reward, because otherwise, right, this would be... otherwise, this would be, like, this would work. We know that carbs is super good. I also tried something else this weekend. I have another present for the RL community, exclusive preview here. Though this is not fully done yet. Wrong one. Exclusive preview for stream viewers. Oh, I guess we win. Haha. Yeah, what do you guys think about if I just make all of Atari twice as fast? Right? What do you guys think if I just made all of Atari twice as fast? And actually, what if we train Pong in like 2 minutes? Does that sound cool? What are we getting for training steps per second here? 30,000? How's 30,000 train steps per second do for Atari, guys? 1 desktop, 24 cores. So I'll share this. This is going to be another article in a few days once I have this like fully like tuned and solving Pong perfectly. Because this is like a 2-minute run, I'm pretty sure. Like, let's see, if I do wall clock time here. Relative time wall. Okay, like 5 minutes. Like 5 minutes on Pong here. I think we can get better than that. But I have 30,000 train steps per second with Atari. For comparison, like, you're looking at low thousands with defaults for CleanRL and SB3, like 2 or 3,000. If you optimize like up the batch size and stuff, you can get like high single-digit thousands, but you're not getting 30K. That just doesn't happen. So it turns out we're all morons, and we've been using garbage Python wrappers for like 10 years. And they're just way better wrappers for stuff. I kind of found something like this, but I didn't dig too much on it a couple months ago. Let me show you the dev branch. So, like, the most popular benchmark out there, right, is actually not all that slow. It's just that we completely screwed up. We as a field, I mean. Okay, so ALE Pi, which is the base package with Atari, has built-in wrappers for frame skip and grayscale. Okay? And they're way faster because they're not Python. And then on top of that, if I just go from dev to 1.0 here, this is as it was before. We have this resize observations. This wrapper is garbage. This wrapper needs to be deleted from Gymnasium and deleted from every codebase in existence. This wrapper uses OpenCV for resizing, and this one wrapper throws away 50% of your compute doing a garbage optimized resize. So we've literally just been throwing away half of our CPU for the last 10 years with this trash wrapper. Isn't that nuts? But this is what I mean when, like, RL is cursed and there's no incentive to fix it. Like, we've just been being this stupid for 10 years. Just throwing away half of our compute to a garbage wrapper. And you want to see the fix for this? Like, this is not me being smart. This is, like, us as a field just screwing up. This is the fix. Okay? Look. All I did was... Where is it? No, not this one. Okay, right here. One sec. Pufferlib, post-process. I added the wrapper here. Okay, this right here is the fix. I use NumPy indexing. to downscale by a factor of 2. And it's 10 times faster. Like, this specific wrapper is like 10 times faster. That's all I did. This is not me being smart. This is like nobody having bothered to fix shit. Right? Look at that. Isn't that nuts? So yeah, this is the type of stuff. And you just do this, and then you set some good batch size. You use Puffer's vectorization, obviously, and you hit between 30 and 40,000 steps per second, depending on your training, depending on your settings, your train settings. So far, it looks like this has gotten to 15 return overall. I think 20 is the max. So we got to do a little bit of looking into, what other things I might have changed. Because I think that they're like, I think the wrappers do a couple weird things with actions that make it like hard. I think these are the Mikado wrappers. So I think I have to like disable these at eval time because it makes the paddle jiggle around a whole bunch, like uncontrollably. So I have to do a little bit of work on this, which I'd be willing to do on stream. Maybe I'll do that tomorrow or something if people aren't super into the MOBA dev. I do want to finish up the MOBA dev, though, and get some sweeps running. But, yeah, we're going to have all of Atari just, like, train 5 minutes per env. Train maybe 10 minutes per env. 1 GPU. Standard desktop. Heck yeah. I'm actually seeing some rewards that are up by 20. What happened here? This actually looks like it's up by 20, right? Why do I not see this on the graph? Maybe it is solved. Oh yeah, it's solved. Why does this one not show up? Wait, why does this not show up on the graph? Does it only show you 100 runs? Wannabe, why is my... Oh, it does show up. I wasn't reading the axes right. Okay, so this is basically solved. We gotta, like, disable the Mikado wrapper at eval time, I think, but this is solved. How long does this run take? Right here. Let's do, actually, this one. Let's do, yeah, this one here. Stable by around here, I think, right? And this is, like, tiny little bits. Heck, you could even take it right here. This is 18, which is probably without the eval, like, without the instability from the wrapper. So this is, like, less than 10 million frames. Basically, sample efficiency matched with the original. Let's set this to wall clock. 5 minutes. 5 minutes to train Pong. Default settings are like an hour. 10x speed up for free. I'm pretty happy with that. Also, I did something that's kind of good and kind of bad. I just hard merged everything into dev. So it's going to be a little less stable because, not everything's fully tested. But if you want to get access to all the stuff you see on the stream and all, like, these new things I've been talking about, it's no longer in, like, some obscure branch that's going to get deleted. Everything's just in dev. Try it out. Let me know how it works. We've got a discord.gg/puffer, which you can join if you want to contribute to the project in chat. We can definitely be looking for contributors. I got to get some more machines at some point soon. I got to figure that out because I've got these 8 and they're pretty nice. But, like, I've had so many damn issues with the Intel chips in these things. I just happened to get, like, bad chips in this batch on, like, the one generation in which Intel has some instability issues. So I'm probably going to look into, like, AMD builds for the next expansion to these. For now, they're okay. They just need to be rebooted once in a while. But yeah, these types of hyperparam optimization graphs where it just gets way better over time like this is going to be the new norm. All right, anybody have questions or stuff on the hyperparam stuff on the article? For folks that just joined, we just went through this article that I wrote on hyperparameter tuning with carbs and how nothing else works. Fail, fail, and then carbs just solves everything. Anybody got questions, or should I move on to MOBA dev? Because we're doing a relatively short stream today by my standards. I think I've got 3.5 hours from now to dev, and then I've got like a couple hours worth of meetings, and then I'll probably be back for like another couple hours in the evening. So I'll give the stream a second to sync up for any questions, and if not, I'll start on MOBA dev. This is also going to be a relatively chill dev day. I am absolutely not operating at 100% mental capacity. Actually, I want to brag about this a little bit. Because this is why I'm exhausted. Yeah, so this was my yesterday. So I'm still pretty much fried from this. This is 3,000 feet elevation, 22.5. So it's going to take a minute for, it's going to take a day or two for me to get back from that. But this is going to be a good dev week. Any situation where you wouldn't use carbs in reinforcement learning. I'm sure that there are going to be some degenerate cases, because there always are. But, like, I don't think that there are any cases where I wouldn't try carbs from the get-go. The one thing I will say is, like, for carbs to work, I do think that you generally need to have, like, a reasonable set of starting hyperparameters. Like, if your starting hyperparameters are way off and get 0 reward, the way that carbs work is it defines a normal distribution around the center values that you give for every parameter. So if you're way off, it's going to be harder for carbs to find the initial, like, good solution, even compared to like random search. But that's like a really, like, that's just like a user error. That's basically a user error. Oh, the other thing, I added one additional thing that I think is very good for carbs. And this is a type of thing that we need more of. So, and I didn't have a great way of doing this. But Pufferlib has in dev now. If you look at the demo file, this is just, where we have all our starter code. In the train function, after I train, I do 10 additional evaluations. So I do like 10 additional data collection steps just to collect stats. And this is because I try to get a smooth estimate of the return. So carbs is pretty sensitive to noise in the return value. So if you just give it like, one environment return as the final metric, like that's a really noisy estimate of how good your hyperparameters are. So what you want to do is you want to have like a pretty smooth estimate of the actual return that this experiment got. It's pretty sensitive to that because of, like, it's an improvement over time algorithm. So if you give it conflicting data points, it gets confused. And technically, if carbs finds that they're like no good solutions, if nothing is Pareto optimal, basically, which is, I don't even know how that's possible, but I've seen it happen, then it'll just like stop being able to run. It just won't be able to run trials because like it just throws its hands up and says, hey, this looks like a nonsense problem. Any other questions on this stuff, or are we doing MOBA dev? Okay, thanks. Yeah. The MOBA's made some progress. We left it in a pretty good spot on Friday. We are only 1250 lines of Cython for this entire implementation. This is all part of the master plan, right? Like, in my mind, you need ultra high perf simulations for getting really fast feedback on how your algorithms are doing. You need really good hyperparameter sweeping for making sure that you're actually evaluating the best possible version of the thing that you're doing. It's really hyperparameter sensitive, right? And if you have all of that, then you're in a spot where you can make really, really fast experimental progress with RL. But we're missing all that in RL, right? It doesn't exist. That's why you got to build it. Perhaps I shouldn't advertise this too heavily because We are somewhat hardware constrained. We only have these 8 boxes until I get some more. But I do give hardware access periodically to contributors to Puffer. So if you have some stuff you want to do and you need a box to run like some cool experiments on for that contribute to Puffer in some way, then I can potentially set you up with access. That's the one other ad. Did we hit? Let's see. Have we hit 700? Who wants to be 700? 1 star. Come on, somebody do it. Somebody do it. Hey! That's awesome. 700 puffers. Thank you so much. That's amazing. Actually, no, again, it was always... There you go. Thank you so much, guys, for that. That's awesome. All right, well, I guess then we're starting on MOBA Dev, which is going to be a fun time because when we left this thing off, oops, this is not my post timeline. Where's the last demo I posted? Okay, so I posted this demo where you have like basic playable games. You have RL teammates, RL opponents, 1250 lines, runs carb sweeps, all of that. Oh yeah, if you're looking for another fun article to read, I recommend this one. I gotta repost this next week. I think I posted this at a dumb time where nobody saw it. Here, I'll give the link to this. This is just a really fun post where people are saying dumb things about AGI. This is a fun alternative. But yeah, here's what the game looks like, right? The darker blue ones, or the brighter blue ones, I should say, are the RL agents. You can see the minion waves coming out in front. You see the towers in orange. And this whole sim is like 1250 lines. So when I ran this carb sweep this past week, it didn't do that great. And this is the same code base that has done Pong and has done everything else. So we know that the code is good for that. And the MOBA sweep, if we look at it... Nope, other one. The MOBA sweep here, oops, didn't do very well at all. And we can actually see here that the level means basically aren't doing anything. So this is not really learning. I left this running just because I can, and just to see in case it happened to find anything. But yeah, this is not learning. So what we're going to have to do today is we're going to have to get some proper sweeps running. We're going to have to tune some various different reward functions. We're going to see what's wrong. We're going to make it so that the agents can use their various different skills, because those are disabled at the moment. And basically, we're going to figure out what the heck we broke in the last refactor, because the environment is substantially cleaned up at this point, and really, as soon as we start getting decent policies trained, we're going to be able to start balancing and stuff, and then we'll pretty much have a final product done. And then from there, like, I'm open to spending a lot more time on this and like making it way closer one-to-one with actual Dota instead of like this kind of like very small toy mini MOBA thing. That'll just depend on how much people are interested in the project, right? If I see a lot of people If I see a lot of people like checking it out on Twitter, if I see a lot of people using it, if people are like interested in contributing to it and using it, then I'll go more after that. But at the very least, we're going to get it to the point where it's like a useful research env where agents are learning some cool stuff. So let's start on that. Oh. Let's add these tests so we don't lose them. Let's see, test. Test files. All right. You can see that there's been some changes. There have been some changes. Where are we here? Setup, build. It's kind of cool that we're starting to see some actual like contributors joining the Discord as well. It's going to make it way easier to get going on this stuff. And one of my collaborators is back from vacation as well, so we might see more stuff on the continuous control side with Puffer, which I know there's some robotics folks around that like that type of thing. Okay. Let's make sure that this all this runs to start with. This is how you would run it if you want to download it yourself. Mode, eval, render, mode. Let's do raylib. This is not loading up any policies. I have it running too fast at the moment. Let me fix that. And let's just do eval model path moba.pt. I think that this is an updated file. We'll see. Okay, here you go. Here are these trained agents from before. This is from before we like messed stuff up apparently. So we must have just messed up the data or the reward function, I suppose. The agents kind of filter towards the center. They'll fight some of the neutrals. They'll do whatever, right? I'm noticing that they seem to be destroying the wall periodically, which is kind of weird. So, first order of business is going to be... If I just play this in human mode, I might be able to find some of the weird bugs. Right? Just by, like, playing this, I might be able to see, like, oh, that's obviously wrong. So let's see if this plays reasonably. I can move around, right? What happens if I go fight a neutral? Do I do damage to it? Yep. If I get close, it follows me, right? I can lure it into the tower. Didn't seem like I could lure the neutral into the tower. Maybe that's not a thing, though. I take damage, right? If I get farther away, do I still take damage? No. We can see this one here is being killed. Oops. I see I've leveled up. Leveling system appears to work. My max health has gone up. So that appears to work as well. And the wave comes to fight. The wave gets distracted by minions, right? And then, yeah, there's a render bug here. Eventually, there's a render bug I gotta fix. But so far, the sim looks reasonable. Do you think it would be nice if there were a verbose showing the stats of these Dota agents, level XP, etc.? Watching reward. There is. During well, there is this for training. We have log time stuff for training. So if you go into Wandby here, we have the level mean for Radiant. We've got the reward for XP. So we have like all the different components of reward. Here's the reward for getting XP, the reward for dying. We've got the max, min, and mean level for each team. What else do we have? We've got a reward for destroying towers. We've got position, X and Y. We've got reward for going towards the enemy ancient. And such like that. So, yeah, we should probably add some of this as an overlay, like an optional overlay to the human gameplay. That's something that we're going to do while observing gameplay. Yeah, I agree. I agree that that's something that we're going to want, for sure. Though it does look to me that at the moment, this looks to me like a scaling issue at the moment, because, like, the reward is just super low, right? Like, the reward is too low for this to be learning anything meaningful. I wonder why that is. Okay, here's reward distance, 0007. So it looks like I probably set the reward for just going towards the enemy too low, would be my initial guess. Here's the reward for dying, which is like 0 because they don't do anything. Reward for XP. You know, I could use this as an opportunity to do something really cool today. I've been thinking about this for a while. So why don't I just expose the weights for these rewards to carbs, right? So that carbs can actually sweep over these different rewards. And then we'll use like a ground truth metric. We'll use like, you know, game length. Like we'll use like time to win or something like that in order to select which of these is better. Or we'll like use like player level or something like that in order to select which of these is better. There's a feature that I'm going to have to add in, which maybe we'll dev this week, but we need to have like a good elo metric as well for our trained agents. That's really what carbs needs is elo. Elo's a little hard to do though. Hyperparam sweep for reward weightings given saved weight. Yeah, so it's the hyperparam sweep would set different weights for each different component of the reward. The hyperparam sweep would set different weightings for every different component of the reward, and then we would use something else that's not just the reward as the metric, right? So we like the metric for which run is better would be something like average level or something, right? Something that's not just immediately dependent on the reward. That would be the idea. This type of thing has been done before. You know, this type of thing has been done before. DeepMind has this population-based training paper where they did that like several years ago, but theirs required a whole bunch of hardware. Whereas this, I think we can just do this and have this work. That'll be fun. Let me see if anything's blown up on X real quick. 1 second. Let me... Let me see. What in the hell? Okay, never mind. All these messages are just spam. Cool. Nice. Let's do the thing that I just said. Let me move this. Let's add the rewards in. the reward weights in. That'll be a fun thing to do. So the way to do this, there are going to be two parts to this. The first is going to be to see how we currently have them. Okay, so right here we have these as constants, right? We're going to move these into the init function of the environment. There we go. Reward XP, reward distance, reward tower. And then we will do reward. Okay, we set the reward components. And then we look for reward underscore like this. Any others? Nope, that's it. Now we get to take these out. And we get to put them as arguments to the environment. So we'll do discretize ward death equal negative 1.0, 3.0. Okay. These look good. So let's now pass these, I suppose, to the environment. Yeah, we'll pass all these to the environment, and we'll see if it works, and then we'll add them to the carb sweep. What order do I need to do that in? So they're currently the last arg, so after discretize. Discretize is just hard-coded to true there. All right, there we go. Reward death, reward XP. Is this it? Death, XP, distance, tower. Yeah, that's the right order. Cool. Now we do Python setup.py. No attribute reward death. Really? Take this watch off. CMOBA has no attribute reward death. Okay. Right, I have to declare them up here as well. No big deal. Forgot to recompile. Appears to work. That's probably reasonable, right? Is getting some reward here. Actually, notably, this file that, oh, wait, negative? That's funky. All right. It runs at least. Now, how do we integrate this with carbs is going to be the question. Let me think. right now with carbs, we have a sweep config, which gets pulled out somewhere. Where's the sweep config? Sweep. Args of sweep is all it is. So config default, do we have sweep? Oh yeah, perfect. I think we literally just add this in here. We're just gonna have to make yeah, we're just gonna have to make like a reasonable setting for this type of stuff. So here are our rewards. And we should just be able to add this in here, right? Like we just add like sweep parameters dot env dot parameters dot reward death, right? Now the way that this works is that it defines a normal distribution around the target. That could be pretty aggressive, right? If you define like a normal distribution around the target. So we're going to have to think about how we handle this. We'll go look at the actual graphs. Let me just put something for now. Default, uniform. Let's do -5 to 5 for like death. Because those are like the max reasonable clipped rewards, right? Reward XP. 0.0 to 0.01 or something, maybe. Max reasonable. Because it's per XP point. So I think that that's a lot. We can do 0.5. Reward distance. 0 to 5. Reward tower. There's no reason this should be a positive death reward. Okay, so now we have bindings for these at the very least. We're going to want to center these, which is one of the kind of the awkward things, is like we need to be able to define the search center for these. And we don't really have the ability to do that with wand-B sweeps at the moment, I don't think. That's going to be one of the smaller issues where we'll have to hard code maybe. That's okay. We can do that for now. Can we get reasonable ranges? Let's see what this sweep did. So I gave this thing like logit space JE lambda, and it kind of stayed in this range. So logit space is nice if I have something that's going to be 0 to 1, maybe. X space is kind of interesting, or log space is kind of interesting. I actually don't know how it makes use of these spaces, to be honest. I think we can just try this for now and set like reasonable means, maybe. It'll be somewhat inefficient, but we'll be able to tune this later on. Let me see how we're going to get this into the environment in the first place. Ugh. I've got 2 big cookies and a coffee to keep me awake for the next couple hours. Okay, so this is where we need to add this. I need to give search centers -1.0. Yeah. So what I'm doing here is I'm adding some special case stuff for the MOBA because we don't have a way to do. You can't specify search center in a config. WANB doesn't let you. So we're just hacking around it for now until WANB gives us a native integration. I think these were the values we had. Okay, so now we actually have all these parameters, which is very nice. And all we need to do is figure out how to pass them to the actual environment. Args of train.update suggestion. Well, this is now awkward because we've got a bunch of awkward stuff going on essentially because of restriction of having to hack around WANB's API. Like, if WANB had a custom API for this, it would be way easier, but since there isn't one, we're having to hack a bunch. So we need to basically figure out how to come up with groups of parameters here. Let me think of a good way of doing that. I think I want to add a group here, right? When I add this, this group thing, because I have, carbs param of reward. And what do you pass? You pass train params. Yeah. So I think you need to pass a group right here. So we'll do env is the group. Env. Oops. What did I do wrong? And we're going to make it so that so this thing can recognize multiple different groups of parameters. So this will give us a nice improvement. This will be train. In fact, all these are going to be train. Do I trust this thing to actually give me a good correction? Let me make sure it didn't make any mistakes. Looks good to me. Okay. Do we get rid of this part? I think we get rid of this for now. So these are the train params. And where did we define wannabe train params? I think this is just sweep parameters now. All these places we have train params, it's just going to be sweep parameters. Perfect. And now we have to modify this carbs param function in order to take a group. So wannabe param is going to be wannabe params of group parameters name, like this. Value gives you, values. This is fine. Then you get the space. This is kind of awkward here. I think you need to do like group underscore. Yeah, let's do group dash. Group dash name like this. And then here where we get the suggestion. And then we'll get train suggestion equals I don't like doing it this way. Yeah, so okay. There you go. So now we're going to get the train suggestion and the environment suggestion. And then this is going to be updated with train suggestion, right? This is train suggestion. Don't need this anymore. And that's fine. And now we do args of track. That's fine. Args of m dot update m suggestion. And that should be it. So now we should have access to args of env. And then we call train with args like this. And we should be able to do, yeah, env keyword args is args of env, right, like this. So this should already work. Let's see if this works locally. Load train. Does this give us correct environment loading? Looks like this does maybe work. Let me make sure it's getting added into the environment. So, oh, we didn't add it into the train config. Let's do that. MOBA. That would be an interesting way of doing it as well. Let's do env, right? So we have the env params here. Yeah, and then this is going to give us, this should give us an error, I believe, because these should be unexpected parameters. Yep, got unexpected. Keyword arg. Reward death. Now we have to go. Make MOBA. Reward. Reward death. Does it not know? It kind of remembers. Oh yeah, it does. That's nice. It remembers remembers the args and their values. Okay. And now we just have to add them here. Reward. Nice. And if I just buffer lib environments ocean MOBA. Oops. And we just like print reward breakpoint like this. We should see this passing correctly. There are our correct arguments. And if I change one of them, we should see them change. Yeah, 5.0. And go back to 3. And if I run this with multiprocessing, does it still work? Yep, still works. Cool. Is it slower? That seems slow. We'll have to see what happened there. Some people are seeing this. Can I just run sweep carbs and have it work? Missing 1B params. Carbs param of, this is train, and this is sweep params. Let's debug this and get this on the board so that we can start automating all of this runs, all of this training. I think this will be the thing that really makes it work nicely, is being able to just sweep the rewards. Tuning these is obnoxious. And then what we'll do is, like, in future runs, we'll just be able to tune from the starting point. Okay, is this running? Hold on, is this already running? Let me see. Carb sweeps. $37 seconds. MOBA. I click overview here. We've got parameters. It's not logging this, is it? Train, sweep. Oh yeah, here it is. Look. We've got the rewards right here, right? So this actually works. Let's push this. This is actually what I was going to do with Atari as well. I was going to mess with the some of the env parameters. So I think that we're going to do both of those today, maybe. That would be fun. Fig, Ocean, MOBA. We'll do update, add env rewards, sweep. I'm realizing now that we need to change the metric then, don't we? Yeah, we need to change the metric. Because, okay, so the issue at the moment is we can't, if we're changing the reward magnitudes, we can't then, like, optimize for higher and higher reward, right? Like, we need to have something else. So let me figure out what we're gonna change. I can just make it like Radiant team level or something. Radiant level mean for now. I think that's really unstable though, the way I'm logging it. What if I make a norm reward? What if I just make like a normalized reward metric, right? So I was thinking of like dividing the rewards by their weights or something, but that's also kind of janky, isn't it? Hmm. Oh, I have an idea. I got a cool idea. What if I were to make a metric that's like total towers taken over the course of training, right? So we just directly optimize for like maximum game progress. The game doesn't reset until you win. That seems good. Yeah, that seems good. I'm gonna have to code that in, but that seems like a good metric to use. Sparse reward like achievement. Yeah. So achievement's like always the type of reward you want, right? Achievement is just like, can I have some like breadcrumb trail that tells you how many breadcrumbs you've gotten towards the thing you care about, right? You don't always have that though, right? I mean, I could define that like for Dota, it would probably just be like towers taken, right? And this is not a matter of the reward. This is independent from the reward. This is so the reward is what you train on, right? The metric we care about now, this is for evaluating how well a specific run has done. Because like if I double the reward, right, then you'd expect that it would be twice as high total reward on average. What we care about is like game progress. So we want like number of towers taken. That'll be good. Buffer lib. How do I want to expose this? Well, the thing is, the towers taken metric is also kind of awkward because it optimizes for short games, doesn't it? It just optimizes for like you both rush past each other. Hmm. Really, what you want is you want elo. So, okay, let's look at this another way. We know that we're going to need elo at some point in here because elo has to be the metric that you optimize for. It's an adversarial game, you have to have elo. I have an implementation of elo. It's just that like evaluating versus past agents or whatever is kind of complicated. That's not happening today. I'm too tired to implement that today. Um, Possibly later in the week. So in the meantime, can I just come up with something reasonable? You know, why not? Let's just optimize for towers taken. That seems it's better than nothing. Um Public total towers taken. Oops. 0. It's not going to ever get reset. Right here. Total towers taken plus equals 1. And then we will do total towers taken in the infos, which is numpy mean Where do we get this from? Radiant levels. Radiant. Oh, you have to iterate. That's fine. You have to put this in a list as well. Cool. So let's see if this now works. Config MOBA ocean MOBA environment / total towers taken. Okay. And we're going to get this running on the big box. This might even incentivize playing in multiple lanes, who knows? What happened? Oh, I already pushed. Okay, we're good. I just do not feel great today. Dang. Vision sharing between agents. That's harder. Oh wait, I missed a message. Hold on. Vision sharing between agents is much more of a pain. Is absolutely much more of a pain. It's not as bad for Dota as it is for other games. But I can potentially do that. That is not out of the question at all. Like I know how to do that as well. It's just it would take some work. Let me think for a second. What did I? Every agent for itself. Yeah. So it does have vision sharing, but like they are using an independently acting model on each agent. It doesn't mean every agent for itself. It just means like, yeah, you don't get like the shared vision on the minimap like you do in Dota, right? There's a lot of stuff that's not one-to-one yet, right? We're trying to get the basics working first. What's running on this box? This one's running Pong. Let's go to the other box. I suggested to somebody in here in the chat last week that if they wanted to learn how to write super high perf M's and wanted to contribute to Puffer, they should do like ultra high performance breakout. That would be cool. We'll see if they actually do it. That'd be a nice addition. Okay, so first of all, how fast is this train currently? I don't need this anymore. How fast is this train? Oh, well, I've made a bug, so. Yeah, this is now training way slower than it was training before. So we'll have to figure out why that is. I'll launch a little sweep in the meantime. And then I'll debug that locally. We'll run a little sweep in the meantime. Oh, this one runs fast. I guess it's just hyperparam settings then, right? What do you have what do we have as defaults? Batch and mini batch. I've got 64K mini batch by default. That's possibly just too big, right? Yeah. We're going to have to add gradient accumulation and other things for this project, I'm sure. This is going to be the first project that really needs the much larger batch sizes. There's this fun blog post. Really good blog post. So, what this says is that when you're training Pong, you don't really get advantage over using mini batch size like a little over 1,000 here. And when this is batch size, if you're not doing gradient accumulation, this actually means mini batch size. So that's important to know. Some of the Atari ends are higher, but like mostly, you know, most of them are like under 10K. Breakout is up here, whatever this is, like 7,000, I guess. The Dota 1v1 is over here. And then the Dota 5v5 is over here. So this says that you get like linearly better performance for a long time on complicated environments. Good post. Where'd the curves go? Oh, they used to have this really cool graphic on here. They redid the blog and they killed like a lot of the cool features on the old post. There used to be like this interactive thing where you could like slide a loss curve. This was one of the best posts that they had. It's funny how me posting about stars is better than me posting articles, apparently. But hey, we're happy. We're happy with the puffers. 701. Welcome back, Will. Oops, let's check on the sweep, see if we have anything cool. Yeah, so this will probably take forever to run sweeps. We can optimize some other stuff in the meantime. Wait, are these the exact same curve? Oh yeah, because it's only getting a reward for distance at the moment. That makes sense. So in the meantime, we can think about like what other stuff we might want to potentially optimize in here. I've got a little over 2 hours, it looks like. Jeez, I'm just so freaking tired today. It's nuts. Don't feel great either. Let me think what we can do on this project to make this like really solid. I mean, perf optimization is always nice, right? Because I want to re-enable skills and stuff, but I don't necessarily want to do that until we have working models. So I'm going to bet that unless we made like a major error somewhere, probably it's just the reward function. Right? Probably it's just like the reward function being wrong is why it stopped learning so well compared to previously. And the fact that the old model file still works well on the new version of the environment leads me to believe that we probably didn't mess up the observations. Because if we messed up the observations, the old model wouldn't work, right? So I think it's just that we changed the rewards, we rescaled everything, and then the new scaling was bad. That's my guess. So let's do a little basic perf optimization. Oh, wait. We could also do the thing that we just did for breakout and see if that does way better. That's the thing we could do, right? Let's do that real quick. Because if that works, then I'll be able to do a little article on that midweek, which would be cool to see. And this would also help us validate this idea of like env tuning in the first place. I know a bunch of people like this stuff for curriculum learning. So let's do that. Here are our Atari params, and we're going to open up pufferlib, environments, Atari, environment. Oops. I see frame skip here. I know there's more than just that, though. Let me go find the arg name. We're just doing this because it's like the same technique we did for the MOBA. It's a nice thing to run in the background. And then we'll do a little bit of perf optimization. And then I'll break for meetings because that'll probably take a good couple hours to do the perf optimization. This will probably only take like 20 minutes. I'll do a little bit of perf optimization. We'll see if we can get the environment comfortably, you know, above the million step per second or whatever. Like fix some stuff up there. And then I'll break for meetings. And I'll probably come back in the evening afterward, depending how I'm feeling. Okay, so here are the actions. Difficulty. We leave difficulty off, I think. I don't know if we want to mess with that. Mode. So it's just frame skip and repeat action prob, I think, is all we need to care about. Frame skip, repeat action, probability 0.25. There's like something with sticky actions I think that we need to be careful with before we post this stuff, but nah. Okay. That's fine. And now all we do is we grab these args. I am. I'm letting the MOBA run a couple of sweeps. So I just did the exact thing I'm doing now. I just did for the MOBA. I'll show you right here. Yeah, so it just got to the second experiment. So it's now sweeping over reward weighting. So it's sweeping over environment-specific parameters. This one looks like it's already doing better. So I'm letting it do a couple little experiments in the background. So I'm applying the exact thing that I just did to Breakout just as another test. I'm going to run this in the background. Then I'm going to do some perf optimization on the MOBA. And then by then we should have some runs done. Because what happened with the MOBA is, so I did this giant sweep over the weekend. And it didn't give us like any good policies, even though carbs is really good and we know that it works. And the only thing that I changed was I changed like some of the reward weightings. So what I do now is I added the reward weightings into the sweep, so it can hopefully also figure that out for us. And I'm letting it collect some data. It's not going to take very long, but I figured I'd just add this to Breakout while I'm waiting, just as another sanity check on here, and then I will go back and do some perf optimization. So that's what's happening at the moment. Basically the same thing. All I have to do is distribution should be what, uniform? What did I do for like gamma in slash config slash default gamma? Yeah, uniform. Okay, that's fine. Let's check the demo file and just do the exact same thing that we did for MOBA. Which is right here. We just add linear search center is 4, which is good. And what did we call it? Is linear? No, this is logit, right? For repeat action prob. Logit. 0.25. And that should work. So let's see if, whoops. Let's add these as defaults, see if it works. And I'm going to actually bump this up so I can just test real quick. So we're going to do 0.5. Tari. Let me make sure this works. Be a good sanity check for the MOBA as well. Python, demo, and Tari mode. Right. And if this passes correctly, then that should be a good sign. We'll do Pong. Was it repeat? That's not good, right? Repeat action prob. Why didn't this pass? Okay, so that's a good thing to know. So we potentially have some bug here. Repeat action. Repeat action probability. I have it right here, don't I? Oh, dumb. Like this. I did that correctly for the MOBA, though. Yeah, 0.5. Perfect. Now this goes to 0.25, which is the normal version. And we should just be able to open that, move the breakpoint, commit this. I have a spare box for this as well. And then we'll see if that sweep does any better. Let's make sure this doesn't error. Invalid type float. Okay. We forgot one thing with this. Is integer. And let's see if this works. Looks like it. That's 37k, 35k at least, train steps per second on Atari. So that's a less than 5-minute train for Atari right there. Okay. So now we're all set on our sweeps. We have a third one on our MOBA yet? Anything? Anybody taking towers? Doesn't look like anybody's taken towers just yet. So it's going to take it a while to find reasonable train settings, but you can see actually, if I zoom in on this a little bit, you see there's env.reward death, env.reward, tower, all these things. So the rewards are now in here as well, which is pretty cool. So let's go back to some perf optimization from here. On the desktop, yeah. Let's see what is breaking, what's breaking at the moment. See if we can find anything that's slow. Well, obviously this stuff calls back to Python. That's allowed to. This is a line that I wish I could make not call back to Python, and it would help us quite a bit. But I really can't. I wish I could, but I can't. This is weird that this cast doesn't work. This calls back because it's public, which is fine. We know that's going to happen. This is all in a init, so we don't care that this runs Python. Oh. Well, there's your problem. Yeah, we have all the optimized, we have all the slow ass end flags on. Let's fix that. Message. Do you think this could be expanded to discover new macro strats in League with each new update? So the thing is, yes, but like it would have to be pretty much 1-to-1 with League, and it would have to be way faster than League is now. Because otherwise you're looking at the scale of compute for Dota. I think that this could be done like successfully at the scale that Riot would be willing to invest in. And I know actually Riot has done a fair bit on the reinforcement learning side. I offered to do some stuff like this with Puffer for them, but I think they were kind of doing their own thing at the time. But yeah, this is absolutely the type of thing that's going to just get easier in the future. And I don't know if game studios are going to be the first major adopters of this stuff, but they will be adopters of this when it's like more consistent and easy down the road, which is stuff I'm building towards. It's all stuff I'm building towards. I mean, this is kind of the plan with Puffer, right? Is that this tech is just going to get way more stable as a result of all this stuff I'm building. And then companies are going to hopefully want to use that as it becomes easier. You can use it for free. And if you want, extra features or support, then we can talk, right? Hmm. I actually think Riot would find it more useful because they'll be able to use it to prevent them from releasing broken shit with updates, right? So it makes more sense from the game balance perspective to have the game company using it. Because you're not going to be able to do something like this on League, like 1-to-1, without deep cooperation from the game developer anyways. And, like, this stuff is intensive and expensive to do. So, like, that's just never going to make sense. But it's totally something that Riot could do, if they wanted to. I wouldn't even necessarily recommend doing that just yet, because that's a really hard RL problem. But it's definitely something that could be done, cheaper and easier in the future. Okay, way better. So, once I took all the dumb flags off, this function runs in pure C. Why do I have this add traceback? Pi add traceback. I mean, why do I have this thing that looks like a function call? Is this just the annotation itself? Or is this traceback saying that, wait, line number? This has got to be like the pi x add traceback. Hmm. So this could be spurious. I don't know if this is a real... I really don't know if this is like a real error. This looks like it's adding something for the Python. It looks like this is adding the annotation itself, but why would it be adding an annotation here? Like, it shouldn't be, right? Not all my functions have this, right? Do I have some functions that have... Yeah, see, like this one here doesn't have anything. Do I have any functions that don't have yellow? They all have profile disabled on them. Maybe I should do app profile off or something. Okay, so like aside from these high level function calls, which are for some reason, yeah, so this one is definitely like calling back to Python, right? Memory view length. Yeah, because I don't, this is not typed is why. So like there are a few small things there I can fix. But then these are all just the function calls themselves. This one is the one that I can actually fix. Levels one I can actually fix. What in the heck? Okay, so this spawn function's apparently slow. Pi int from long. I have it typed here, right? Why? Pi int from double. I don't know why a cast like this would trigger a callback. That's weird. Scan AoE here is triggering this. Even though scan AoE is in pure... Oh, it doesn't have a return type. Okay. We can work with this, right? Let's start making some basic optimizations. Jeez. I'm kind of suspicious about this one. Let's try this. Is this any different if I do the cast in C syntax? Ah, it is. Int. Yeah, so this actually, look at that. This goes away. We don't care about stuff in that function. We go to level. Okay, this is now going to be int xp, I believe. Yep. Int xp. And then this length thing doesn't work. So there are 30 levels. That ought to work. And now we'll have that function in C. That's one other function call avoided. We haven't messed with like compile flags yet at all. That can sometimes be useful. Okay, this is now in pure C as we expect. These signatures are bothering me. Like, I don't know if these are actually calling back or not. We'll have to check this. XP for player kill. How the hell is this calling back to Python? I would love to know how the hell this is calling back to Python. Pi error occurred. What? How can there be a pi error on a C function? That shouldn't be possible, right? Where'd it go? If unlikely, it's like whenever you return an integer, it decides that -1 could be an error code, right? Wait, but isn't this short-circuiting? Wait, hold on. I think that this is actually okay, isn't it? Because this is a compile time check. Oh, actually, wait, this is cool. Okay, I actually learned something here. So look at how this works. So this is the return value here. This is the int. This is the generated name for this XP for player kill function I wrote, right? And then semicolon, and then it checks the return type. If unlikely, the value is equal to -1, and pi error occurred. This is the part that calls back to Python. This value can never be -1, so this short circuits. This never gets called. So this is actually in pure C, because what this annotation is saying is, hey, it looks like there's a branch of the code that could possibly return to Python. But because this function is never going to be -1, that means that it's never actually going to call back to Python, so this is fast. That's cool. Now this one is actually a legitimate calls back to Python here, so we got to fix this. I don't know what's up with these casts, but it looks like there are certain types of casts that just like don't play nice. Cast bind tightly to variables, right? So I can just do like this without parens. I like it looking like that. That looks good. Move this window so it doesn't cover chat. Pure C. Scan AoE is missing a return type. That's actually a really big one. I don't know how I screwed that up. There we go. Give it a return type. Mm-hmm. Here, see? What happened here? Pi x, pi int as int. Dope. What line is this? This is no big deal. What's the interpreter you're using to ID these Python calls? So, no, you're good. It's a stream. Like, you're gonna miss random things. It's good. So, this is not an IDE feature. This is a built-in Python feature. If you just compile with annotate equals true, which I have in the setup.py file, then it generates for you every time you compile. It generates you this HTML that tells you where stuff calls back to Python, and it shows you the generated code as well. So that's what's going on here. So I'm just looking for places where it calls back to Python and then eliminating them. And it's a slow process, but not that slow. And then I'm just moving this file up to where it's mounted on my local machine so I can look at it. So like here, I just added a type, right? I added this missing type. I'll refresh the page, int radius, right? And now there's no issue here. So I'll see. Reset is going to call back to Python, obviously, because it's a def. Ooh, I don't actually like that. I think this should be a CP def. Yeah, this should be a CP def. Because you call this internally as well, right? Actually, let me think. Yeah, this CP def. And then for step is in pure C. This path is not. Wow, that's incredibly helpful. Work has pushed me to start using Python, put it off for too long. I mean, Python is really awesome. I mean, it's not... The annoying thing with Python is that there are a few rough edges, because it's like, it's not as big of a project as Rust is, for instance, but it has like such nice integration with Python, and it's so good for so many things that you almost can't not use it. Yeah, it's really nice for a lot of stuff. There's a bit of a learning curve. There's like a bit of annoyingness with the debugging of it. I wish I had a little bit better, like a few better tools with it, but it is quite nice. And it's like, if you're a competent programmer already, maybe you don't have a ton of AI experience, maybe you do, but if you're just like a competent engineer, it's pretty easy to just start building really, really fast simulations in Python. And if you want to get into like RL stuff more, that's a huge way to contribute. Is if you just like build some cool simulators that are ultra fast, and you submit them to Puffer, like that's I mean, that's driving the future of RL right there. We have no good simulators right now. That's why I've been building them. Everybody says like, "Oh, we already have so many environments. We already have so many environments. Why do we need more?" Well, because they're all slow, right? Hmm. Simulator's so slow. Looking at back, this would be better. Your simulator, Puffer has the best vectorization in existence by a huge margin. For like arbitrary m's, so you can do both. You can write this thing, and then you have a one-line modification, like a one-line wrapper, and then you can have it work with Puffer's vectorization. There's technically, it's a little bit more annoying, but there's an advanced API as well that I use for my sims that like bypasses a bunch of the like gymnasium petting zoo API bullshit and makes it even faster from there. Well, that's less slow now, right? Cool. Only thing I want to know is whether or not all these headers here are actually calling back to C or not. I figure that out. Ugh, man. So this adds a trace back. Why does this one have a trace back, right? I got profile false. Function L1 error. I really would like to know what these tracebacks are and whether they're slowing me down. PyX add traceback. It's a CDEF with everything typed. I think this is just the annotate overhead, right? Like these all look the same. This one we already went through is not a real, so we know that there can be spurious. So yeah, this thing should be running pure C. Let's do a little benchmarking. Let's recompile with, well, let's actually see if it makes a difference if I do it with annotate on or off. So we do, could not broadcast, wait. It's a shape 40. It's annoying. What the heck is wrong with this? Could not broadcast into shape. Why are there 40? Oh, numems is 4, I guess. Whoops. I forgot to pull that modification. Okay, so this is 200,000, which is way slower than expected. Let's see if the annotate messes with it. You have to change the file just so it recompiles. I don't know, we'll do this. Should be faster than 200K by a lot. That's really weird. That was very weird. So I guess we got to do profiling then. Let me see. Let me make sure we're not missing anything. Ten M's. Well, that's weird. Why is it suddenly faster, right? I believe this is also 8 or 9, right? 9 valid actions, maybe? I set the device to CPU, so I don't know why it's trying to use CUDA. I don't know if you send another message, but I don't know what you mean. This is out of context. All right, let's do some profiling here. Let's see what it's trying to do. Message disappeared. And resend the first one. I'll run this with C profile, right? Yeah. Let's do this. It might be auto-censoring links if you're putting links in. I don't know what the default YouTube settings are. Okay, that's a lot of stuff. Um, this profile. Run. Wait. cprofile.run. Huh? Sort key. Try this. This is stats dot. Think like you just do this maybe. Okay, so this now gives us timings. This gives us some very weird timings. One second, I gotta go get something. I feel like god awful. One sec. Okay. I think message got removed because I pasted an error. Trying to set up Pufferlib on my MacBook, cloned the repo, and installed the dependencies. I set the device to CPU. I don't know why it's trying to use CUDA. Let me check that for you real quick. What's a really simple env? Some reason I can't write. That's really funny. Weird. Let's do it. Huh. So I see the device CPU there not getting accounted for. Hold on. Yeah, that's weird. Let me fix that for you. see where it's overwriting this thing. CPU. Let me see where it's leaking CUDA. Let me see if this does it. I think it might just be the monitoring. No, I still see GPU utilization. That's weird. Well, I could just do CUDA. Here, CUDA visible. None. Okay, that works. It's really weird. I wonder why it's like... I see the CUDA utilization as well. Yeah, it's not using it for learning. What happens if you do CUDA visible devices equals none? Maybe the thing you fixed in CLI? That probably will. Hold on. Fix. Here. Oops. Skip pull. Diff. Okay, here, you can pull dev and tell me if that works. And let me know if that fixes it. No, I think it probably should. What were we doing? Right, we were trying to debug the utilization here. Utilization really didn't make any sense, right? Oh wait, no, because I remember, so yeah, it kind of does then. So the thing is, we need to have all these functions. That fixes it? Great. Well, there you go, fixed in dev. No problem. I love being able to just fix stuff live. As you can probably tell, I'm kind of out of it today. My like a bunch of stuff just really freaking hurts from the run yesterday, so I'm trying to just make a little bit of progress here and there today. And hopefully we'll be back tomorrow with like way better dev. But we can get a little perf dev done today, I think. Um I'm trying to think which of these functions I want to remove, because what's happening at the moment is I have all these like profile false decorators on functions, and by doing that, um by having these like profile false, I'm like not actually seeing where compute's being used because it's rolling it into the step. Interesting that the creep AI and the neutral AI aren't up there though. Does that make sense? Doesn't make sense to me. So this NumPy core record is really slow. And what other functions are there? This profile graph does not make sense to me. Oh, this is because it's not actually getting compiled with profiling on, right? Let me see. Compiler directives profile equal true. Oh, I see. What this means is half of the performance is being lost to NumPy record calls. Okay. Another bullshit. That would do it. Much better. Hmm. So now we see that the what's this NumPy core records get attribute thing? Where the heck is this being called from? It's got to be being called from MOBA step, right? And all these other record functions that are being called that are slow. Yeah. And this has to just be the logging, right? Do I need to do this? This like self-buff rewards? I don't need to do this, do I? Well, I should put the reward somewhere. Yeah. Get reward. Dot. Okay, just do this. Then have it be in C. I bet this is the slow bit right here, right? Yeah. Does this do any better? That should cut out a whole bunch of NumPy processing. Way better, immediately. Immediately way better. We still have a fair bit of time being wasted on this records processing, though. Night. Thanks for dropping by. Oh, what? Is that a greeting or a goodbye? It's going well. Well enough, at least. Pretty tired today, but we're making a little bit of progress. We've got some cool sweep experiments running, and I posted a couple cool articles. Carbs does really well. How's this sweep going? I started with good night. Alright. Funny enough. Sweep doesn't seem to be doing much, is it? Definitely something weird here. Probably something with the env. What about the other one? We did start a different sweep. Oh yeah, there we go. Yeah, carbs is definitely working. You can see right here, this one's already at 19 reward. So carbs is working. It's whatever we're doing in the MOBA that's not. We'll figure that out. Let's do a little bit more perf optimization first. It'll be so much easier if it's just fast. How often do we want to report performance? Well, that should just be fast if we do this, right? Yeah, it's way better. We just implemented random force without using any library. Now I'm going to learn some OpenCV. Any advice on starting to CV? OpenCV is like the most cursed library out there, man. OpenCV is a pain in the ass library. I mean, it depends on what you're doing. If you're trying to learn like classic computer vision, yeah, that's what you use. If you're trying to learn more modern stuff, I would like I'd spend more time on like neural net architectures and such. Because OpenCV is just a pain in the ass library. Go like implement an MNIST classifier if you haven't done that. Wait, what's this SPS on this? 440. Wait, what? How fast is this? Hold on. If I just turn this off. Cannot assign type float to reward. Right. I see. Okay, I see how to do this. Um, Probably this works, right? I gave it the buffer rewards and a mean self-buff rewards. Yeah, let's see this. Does this do anything? The goal here is to just get as much of the NumPy processing that's in Python into C, or just like less frequent as possible, because it's really slow and bad. From file? Wait, how the heck is from file being called? Oh, that's bad. Hold on. We... Wait, shoot, how do I do this? I guess global. Does this do it? I just want to not time the init in this. The init is slow. Doesn't matter. I'm still seeing functions that I don't like to see here. Put actions here as well. Yeah, we'll just do this for now, whatever. Okay, that is substantially better. Where's the C function? I can't see CMOBA step. But I can see that there's basically no overhead from Python because all the Python functions are now negligible. So that's perfect. And now if I run this without, if I just like run this, what do we get? Up to 300K. That still seems slow. Only 300K. Why would it be only 300K? Didn't we have it at 500 or we had it at 600 before, right? Something must have changed. It's possible this is too many environments. Does it change if I do like 20 environments? Is that different? That is faster. Which is odd. Should not be that big of a difference. Well, with one environment. I think it's still slow with one. We'll see. I had this running at 1,000,000 before, which was like 500-600K on this machine. 300K. I'm not sure. I think we're gonna have to do some profiling back into the C code then. Yeah. What time is it? 1:35. I'll do this another 25 minutes or so. I want to give myself a bit of time before my meeting to, like, I don't know, figure out what's wrong, because I just have not felt great all day. Jeez. Okay, so we build this now with profiling again. Maybe we can see where we're losing out. So, oh, I see a message. Where are you? I'm in Palo Alto for the time being. It looks like the main thing that happened since the last time I profiled this is that compute observations just got way slower. Right? Let me do this with like 20 Ms. Looks like a good midpoint. Jeez. Wait, what? What happened here? The time spent in step went way down? How? Wait. Nine seconds. What was it before? Oh no, that's right. This is good actually. It's all the AI, the creep neutral AI, and then the compute observations, it looks like, right? Let me see if I add these up. Well, no, because there's also this, so I guess that's scan AoE or something. Hmm. There's a lot of stuff to potentially optimize here. It's a good spread. Hey Div, welcome. Trying to figure out how to perf optimize this thing. I had this running at 1.3 million steps per second, and now it's down to probably half that. What would you recommend after making an MNIST classifier for vision? You kind of just want to do a few small projects. I mean, it depends what you're trying to do, right? Like, if you're trying to get into research or more science side, like, you do a couple of the classic basic projects to get familiar with stuff, and then you start, like, either trying to re-implement papers or do, like, really narrowly scoped basic research while reading papers, like, something like that. I mean, there's no real trick to getting into research other than doing it. And you're going to be woefully inefficient at first with your time because like everything's going to be confusing, but you just put in the time and you get better and you get faster and more efficient at stuff. That's literally the trick. That there's no trick. That's it. I'm trying to think what I can optimize here. So half the time is being spent in step. Don't you think too much blue color scheme is bad for your eyes? um I think the blue light thing is probably bullshit, frankly. I think that's like a scheme to sell those dumb glasses. Want to be in research, but I'm thinking about what if I cannot get a job. It's easier to go. It's easier maybe to do like applied AI stuff for sure. I mean, applied AI roles are basically, well, a lot of the applied AI roles are basically like you're a software engineer and then some AI. I'm trying to think where all the compute's going here. So I should just look at it. I had to look at like what functions I've turned off. Oops. That's fine. Nice to have Pufferlib support the MPS Torch backend in CLI rendering for GPUs on MacBooks. Maybe I'll open it. Yeah, go if you open a PR and it works, I'll merge it. Just make sure you PR it to dev, not 1.0. Not sure which way to go yet. Thank you, though. Yeah, it takes time. I mean, I started this stuff, like, literally when I was 16. And, I mean, it took me back then, it took me, like, 1,000 hours to do what would take me, like, 10 hours now. But that's how you learn. Move to is not profiled. Move towards is not profiled. Basic attack is not profiled. Scan AoE is not profiled. I guess this whole loop isn't profiled. I'm kind of wondering if it makes sense to just put these blocks of code into separate functions for the purpose of profiling, right? Like if I just put these into separate code blocks, it would be way easier to tell. I mean, it's kind of dumb to have to do that, but it's really nice for the profiling, right? Well, I got another 15 minutes or so here. I can do that. Camp newt spawn entity neutral. That's fine. Step creeps. Leaving to work on MS. Thanks. Good luck. Yeah, go ahead. Good luck. IDX lane entity creep. All right, so this will be nice because we'll actually be able to get way better profiling data. I hate that I have to like break up the code just for this reason because I would normally never do this. Like I generally will not make functions. Like for things that I'm going to use once like this, I generally won't make functions. But for profiling, it's kind of nice. So you have tower IDX, tower, and that's it. And then we do step players, I guess. Discovered your research. I'll watch it tomorrow. Pretty interesting. Depending on where you're coming in from, there's the thesis video, which is the big one on YouTube, and then I've got like a deep dive on the tech of Puffer 1.0. That's like more technical, and then I've got a bunch of streams on like building stuff. But yeah, thank you. I'm gonna be making more videos as well. I gotta start doing that for sure. And most of these variables I gotta go over there, right? Yeah. Pretty much all this crap goes over there, doesn't it? Step players. If I get this working real quick though, this will be nice for well, this will be nice for figuring some stuff out. Tune in again tomorrow. Great stuff. We'll try the simple vectorization of my M together with Puffer. Python stuff is a deep rabbit hole, but a great one. Yeah, I would just recommend like Puffer. We try to make it really easy. You just wrap your environment in. If it's single agent, Gymnasium Puffer env. If it's multi agent, you do Petting Zoo Puffer env, and then you just call like vec make with that wrapper, and you're good. There are plenty of examples in Puffer with that. And our vec is usually the fastest by a wide margin. Anything is gonna... Oh, geez. If you're using RLib, that's the worst library in existence. I fought that library for years. I tried to contribute to that Yeah, that's gonna be god-awful. Yeah, hit me up then in that case, definitely, because that's... You're just not... You're gonna straight up just not have a good time with that. Pufferlib will seem like magic after that, because it's like most of the stuff that RLib does, but simple. Great to get spun up, but time to move on. It's... The thing is, like, the problem with RLib is, like, they're trying to productionize a field that is fundamentally finicky and requires you to be able to edit every level of the stack. And they're like black boxing every single level of the stack. And then on top of that, they're like, the code is their RLib itself is just super buggy and has bad error messages. So you're just not going to have a good time. Base Ray is really awesome. They've got 5 different AP. Yeah, I've tried to help them several times. I designed a couple of the things for them. Like, they asked me for feedback on their debugger, and I gave them feedback on their debugger and said, like, hey, this doesn't make any sense. Just make remote PDB, like PDB API, but make it work on remote processes. And they did, and it was actually really good. I've tried with RLib several times. I've like given them a bunch of feedback on stuff, but it's just like it's too much big engineering style put into reinforcement learning is the problem. And like, I met Robert at OpenAI. He's a good guy, right? I respect all the stuff they're trying to do. And like I spent like a couple years advocating RLib to everyone because I thought it was going to be up and coming. I thought it was going to solve everything, but I really can't recommend it these days. It's just rough. And like I know a few of the devs on the team and it's like they're good. It's just it like the thing that they're trying to do fundamentally like RL's not ready for. Which is why I'm building Puffer the way I'm building it, right? Everything's really compact. It's all white box. You can go open, edit, and like change stuff at any level of the stack. It's really simple. That's how I'm trying to build. I probably need to run annotate on this, don't I? After encountering CleanRL in your research, becoming a convert, I honestly think CleanRL is the best contribution to reinforcement learning by a single individual, like ever. Cost is just awesome. And it's so funny because you cannot explain CleanRL to like a FANG engineer. They think it's the dumbest thing ever. Like it's so hard to shift the paradigm and be like, look, you can't build stuff the way you're used to building it because this is an emerging scientific field. You can't just wrap every little feature into a nice parcel and then just like black box it because devs need to edit every single layer of the stack constantly because like we don't understand where and why stuff is breaking. So the goal is to keep everything compact and easy to edit, not like, uh like out of sight, out of mind. It's really hard to explain that as well. And like basically the reaction you get from almost every single one of them is like, "Ho ho, I bet the other Fang engineers that tried this just weren't good enough." And it's like, no, that's not the problem. Like kind of yes, but it's fundamentally the wrong approach for this time. Did I just one shot this? Yeah, I think I just one shot this. All right, that's nice. Seg fault. Well, I one shot getting it to seg fault, so good on me, I guess. Probably just need to put the checks on, right? Huh? Now it's not seg faulting? You're gonna be really slow. I don't know why it doesn't seg fault. Turn this one to false. Hmm. We'll see how this sweep does. How's the other sweep doing? Oh, this is just failing is what's happening. Yeah, this is just failing. I can tell. There are too many jobs here. Okay, so I'll have to fix that at some point here soon. Oops. What time is it? Okay, it's 1:57. I gotta go get ready for another meeting, and I gotta fix a couple of things. I'm probably gonna be back in a few hours. Do another like a short evening stream if I'm able to fix some things. And then I will like finish the performance optimization, uh, debug all the sweep stuff, right? And a few other things from there. Now, if you're new to this place, if you're new to the stream, all this is open source. It's all in the dev branch of Pufferlib right now. If you want to help me out a whole bunch, just go ahead and star it. Helps me a ton. And yeah, otherwise I'll be back fairly soon. So see you all.